Hi, welcome back. So this is my second example of second order differential equations using a substitution to transform one equation into another. So this is what we need to transform our original differential equation. We need to use this substitution, y equals z over x, to transform it into this here. Once we've done that, we need to solve the original differential equation. The method there is solve that and then just use the substitution again to get it into the term that you want. So here we go. So this substitution is y equals z over x. So just think about that for the moment. Before I get straight into the differentiation, I don't really want to use the quotient rule because it's going to get rather awkward needlessly. So in a situation like this, sometimes it's better just to rewrite it so you don't have any fractions. It'll make the differentiation easier. You are going to use a product rule. That's unavoidable, but at least that's going to be neater than using the quotient rule. Okay, so z is equal to xy. Okay, so that's what we're going for. And then when we differentiate, we need to get a dz dx expression and a dy dx expression. So what we're going to do is, from that, we're going to find dz dx. Okay, and we're going to differentiate that. I'm going to do that on the next screen for you now. Okay, so here we're at. We want to find what dz dx is using the product rule on that. So you've got this times the derivative of that, so y times 1. We're differentiating with respect to x, so derivative of x is just 1, so that's with the y, and then plus, and then that's times the derivative of that, so x times the derivative of y, and because you're differentiating with respect to x, implicit differentiation means that will be dy dx. Okay. Having got dz dx, our goal now is to work out what this is, d2z dx squared. Okay. And for that, we're differentiating with respect to x. It's always helpful to know what you're differentiating with respect to. And remember what that means is you find d dx of dz dx and you find d dx of the right hand side, y plus x dy dx. I'll write it out like that so you are aware of what we're differentiating with respect to. So the WRT with respect to. Okay. So doing that, differentiating y, you have to do it implicitly like we did over there. So that's just going to be dy dx. Okay. And then this bit, you are going to have to use the product rule on again. So you can have that times the derivative of this. So dy dx times the derivative of x, which is 1, so dy dx, and plus x times the derivative of that. So x multiplied by derivative of that. Nicely, that is in terms of x, because it's dy dx and we're differentiating with respect to x. On the other videos I've done, that's not been the case. So if you're wondering why this has got a slightly different looking result, it's simply because of that. This is dy dx, that is d dx. Because they're both with respect to x, it's a nice simple case. So that's just going to be d2y dx squared. Okay, good with that? And I've just simplified that a little bit, because those two are the same. dy dx plus dy dx is 2 dy dx. So in summary, we've got dz dx, d2z dx squared. That was the original differential equation, and we need to just substitute these in. Okay. Now, there's a strategy involved with this. Let me just share with you what I would like to do. So I'm seeing that this term here, x d2y dx squared, is the same as that. So the simplest way is for this bit, if I just rewrite that, x d2y dx squared, if I write that as the subject, so that will be d2z dx squared, bring that over, subtract 2 dy dx. So that's just my simplest way of doing that one, okay? So the first bit is, I'm just going to do that. So you see here, I'm just replacing that with, as I said, d2z dx squared minus 2 dy dx. This bit, I'm just going to expand the bracket, so 2 times dy dx, okay? And then this bit, subtract 4x dy dx. Now, note this bit, the x dy dx bit is exactly the same as this, x dy dx. So I can make short work of that if I just make x dy dx the subject here and write that as dz dx minus y. So that's negative 4 and then multiplied by what I just said, dz dx minus y. And of course, subtract 4y equals 0. For me, that's the simplest way around. Okay? Maybe you've tried this already, maybe you watch these videos, you pause, have a go at yourself, maybe you got into a bit of a mess. If you got into a bit of a mess, it's because you didn't see that shortcut technique, okay? For me, a lot of these sorts of questions is about finding a shortcut technique to be able to do it more neatly, more elegantly, okay? Here, what's going to happen? Well, when you expand the brackets, you're going to get negative 2 dy dx plus 2 dy dx. Neatly, they cancel. Okay? You'll end up with negative 4 dz dx plus 4y, subtract 4y. Again, neatly, they cancel. So you're just left with the result you need, okay? Which is d2z dx squared. This is the one that didn't cancel, negative 4 dz dx. I did say those two cancel. That cancels with that. That's it. And then you're done. Yeah. Let's go ahead and solve that now. So solving this, usual rules apply with solving differential equations equal to 0, which means it's a simpler case, of course. So you use your auxiliary equation, m squared minus 4m equals 0, which means m must be 0 or 4. And then look to see what category that is. Two real distinct roots, alpha and beta. So you have a, e to the, that's interesting, isn't it? Because e to the 0 is just 1, so that means that would just be a. Okay, so you have a, and then b e to the 4x. Now, just bear in mind that is a differential equation solution in terms of x. Let's just change that. Yep, because you see your answer is z in terms of x. Okay, what we need is, going back to our original differential equation, we need a differential equation in terms of y and x. Okay, so we're going to use this substitution, y equals z over x, to get that. Okay, so here we go. Using our substitution, z equals xy, we can get y back into it that way. So you have xy is equal to a plus b e to the x, and usually you want to write your answer with y as the subject. So y equals, and then a over x plus b e to the 4x over that, okay? Which is our general solution in terms of x, but at least this time it's in terms of y and x, not just z and x. Okay, right, thanks for watching, and I'll see you again.